Example number 8. Use a half-angle formula to find the exact value of the following expression. Sine of 67.5 degrees. Well, my half-angle formula for sine of alpha over 2 is plus or minus, and I'll explain that in just a minute, the square root of 1 minus cosine alpha divided by 2. Now, this does not mean that there are two answers. It means it could be plus or it could be a minus depending on the quadrant. So we have to look at our alpha to decide if it's going to be positive or negative. Now, 67.5 is not our alpha. 67.5 is alpha over 2. Alpha over 2 is 67.5 degrees. So we're going to have to multiply by 2 to find our alpha. So our alpha is 135 degrees. Now, where is 135 degrees located? Well, it's 90 plus 45, so it's right here in the second quadrant. Now, in the second quadrant, sine is positive. And we're doing sine, so we're going to go with the positive. So for us, our sine of alpha over 2 is going to be a positive square root of 1 minus cosine alpha over 2. So our sine, our alpha was 135 over 2 is going to be the square root of 1 minus the cosine of 135 degrees, and all of that is over 2. And now I'm looking at cosine, and the cosine in this second quadrant is negative. So this is going to be the square root of 1 minus negative square root of 2 over 2, and all of that is over 2. So now we have to do some cleanup. I'm going to have a 2 over 2. I'm just doing the inside now. And it's going to be plus the square root of 2 over 2 because that negative and a negative are going to make a positive. So 2 over 2 plus the square root of 2 is 2 plus the square root of 2 over 2. So 2 plus the square root of 2 over 2 over 2. Because this first 2 comes from the numerator and the second 2 comes from this original denominator. So still we have a complex fraction. So let's see what we can do with that 2 in the denominator. So remember, this is 2 plus the square root of 2 over 2 divided by 2. Now be careful. Those 2's are not going to cancel out because it's 2 plus the square root of 2 over 2 times 1/2. So it's 2 plus the square root of 2 over 4. So this is going to be the square root of 2 plus the square root of 2 over 4. And we can separate the numerator, 2 plus the square root of 2 inside a square root, from the square root of 4 and get our final best reduced answer, the square root of 2 plus the square root of 2, all divided by 2. So our final answer is the square root of 2 plus the square root of 2 inside the radical all over 2 outside of the square root.